Hi class. In this lecture here, we're going to begin our study of sets. Now, this lecture here, what it's going to do is it's going to be just a basic introduction to, in mathematics, how we define sets, some terminology and notation. And then what we're going to do in some follow-up lectures is we're going to begin talking about operations on sets, something called Venn diagrams, and then we're going to be building towards what we call survey problems. So this is an exciting lecture, and it's going to lead into a lot of great stuff over the next couple lectures. Okay, so let's begin. What exactly is a set? So a set in mathematics is a collection. Okay, so you can think about a collection or grouping of distinct objects whose contents, okay, so we're going to group all these things together, and these contents are called elements or members. I'll use those interchangeably. Generally, I'll say elements, okay, whose contents, called elements of the set, can be clearly defined. So it's a collection of distinct objects, which we're going to call members or elements, and we can clearly define them. We know what's exactly in it. So a set can be defined by describing the contents or by listing the elements of the set, which is what we're going to do most often. And what you do is you enclose the set in curly brackets. So they're brackets that look like this. Okay, curly brackets or curly bracers. Okay. So a set must be what we call well-defined, meaning that its contents can be easily determined or clearly determined. And then the order of which the elements of the set are listed are not important. However, when working with numbers, which we're going to do a lot of, actually, we will list in order, in numerical order. All right, so we're gonna have this set, which is a collection of distinct objects. It's going to be well defined. The order doesn't necessarily matter at all, but when we do work with numbers, we're going to put them in numerical order. Okay, so how do we label a set? So capital letters are generally used to name a set. So sets will be called things like A, B, C, so on. Okay, capital letters. You can use a word description to designate or name a set. For example, you could say, let W represent the set of the days of the week. Okay. Generally, we won't do this, though. Okay. We're going to quite often use this, what's called roster method. So you use the roster method to list the members of the set. So, for example, if W is the set of days of the week, right, you could just say, well, the set W is equal to, and then you got these curly bracers, and then you're going to just list the days of the week, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And so sets, what I'm hinting at here is sets don't just have to be numbers, okay? A lot of times when we get to operations on sets, we will use numbers, but remember, it's just a collection of things, okay? And here it's just a collection of the names of the days of the week. So commas are used to separate the elements of the set. As you can see here, we got commas as such. And we use bracers like this are used to designate that the enclosed elements form a set. So you can have something, like this. Okay, this would be the set of the whole numbers, let's say 2 to 10. So you could say A is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, just like that. Okay, so you list the elements, put a comma between them, and then you have the curly bracers. And hopefully you draw your bracers a little bit better than I just did. Okay, so I want to now talk about some of the number systems in mathematics as sets. So we have the real number systems over here, okay, and you can see here the circles represent the number systems, and then what's enclosed in it. So like if you look at the innermost circle here, you have the natural numbers start at 1, 2, 3, 4, 5, 6. They go on forever. Whole numbers include the natural numbers plus 0. Then you have integers, which are the negative whole numbers, 0, and then the whole numbers are negatives, the opposites of the whole numbers, excuse me. Then you have rational numbers, real numbers, and irrational numbers. All right, so let's write the natural numbers, the whole numbers, and the integers using this roster method. So the natural numbers. So they actually get a special looking capital letter. So obviously for the natural numbers, we'd use N. But what's really cool about this is they get this double line in the middle here. So this tells me it's the natural numbers whenever you see that. And look, it's the numbers 1, 2, 3, all the way, and it keeps going on and on for infinity. So when you have a set like this, whenever you see, these 3 periods after it goes dot, 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 you see how it's in here? What that means is it continues on forever with that pattern. The whole numbers, all right, they get a special looking W, and they start at 0 and then go 1, 2, 3, 4. And then I'm going to have the 3 dots to tell me the pattern continues on forever. All right, now the integers are 0, the natural numbers, and the opposites of the natural numbers, so the negatives. So integers actually get, this is quite interesting, they actually get, they use the letter Z for the integers, believe it or not. And so it goes all the way down, it keeps counting in the negatives forever. So you're going to have 3 dots to start, then -3, -2, -1, 0, 1, 2, and 3, and then 3 dots to let me know the pattern continues. Okay, so these are just number systems as sets. Okay. All right, so what we've been doing here is we've been listing everything in what's called roster method. So there is another notation or another way you can name a sets, and it's what's called set builder notation. Okay, so it looks like this. All right, we're gonna name the set W. Okay, so we have set W is equal to. All right, so that's the is. X. So first thing we'll do is we're going to put here X. We're going to call all the elements X. Okay, so it's the variable. Well, how is X defined? So then you would have this vertical line here that says such that, and then what comes after that such that is how the set is defined. Okay, so W is the set of all elements X such that X is a day of the week. And then we know that, right? So, we read this as I was saying, set W is the set of all elements X such that X is a day of a week. Before the vertical line, you're always going to put the variable X. And this is just going to represent an element in general. Okay, I'm just going to say X. Well, then what is X? So after the vertical line is the condition of X. Okay. All right, and that must meet in order to be an element of the set. Okay, so for example, suppose we have this set. Okay, here. We want to express set A, which is, set A is the set of all elements X such that X is a month. It's a month that begins with the letter M. Okay, and let's take this and put it into roster notation. So what months begin with the letter M? Well, I think that's just March and May. So both those sets tell us the same thing. One is in roster method. And this right here, this is the set builder method. All right. We're going to do a lot more examples of these in the coming slides, so don't worry too much about it. We're gonna, if you're kind of like, even as you're watching this lecture now, if you're kind of like, oh, this is a little confusing, Matt, I promise you we're gonna do a ton more of examples here. All right, some other things here. We have some notation in sets, okay, and this is notation for set, what we call set membership. Okay, so how you know that a specific element is a member of a set. All right, so we use this symbol to represent membership and this symbol to say that it is not a member of the set. Okay, so the symbol, this right here, this symbol, kind of looks like an E, like a stretched E, is used to indicate an object is an element of a set. So the symbol E is used to replace the words is an element of, okay? This symbol right here with a line through it, so it looks like that stretched E with the line through it, is used to indicate that an object is not an element of a set. Okay, so this symbol here is used to replace the words is not an element of. Okay. All right, so let's take a look at this. Let's let A be equal to the set, and it's just the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, to denote that 2 is an element of the set, this is what we can write. 2 is an element of A. Like you could also say something like 5 is an element of A. 8 is an element of A. 9 is an element of set A. But then what you would see if you wrote something like this, 15 is not, it's not an element of A. Minus 5 is not an element of A. So that's how you would use this notation here. So this is fun, right? So let's write the natural numbers, the whole numbers, and the integers. Okay, with this symbol, with this notation, okay, using this set builder notation, and we're going to go back and use this notation here. All right, so the natural numbers. All right, well let's just define it this way. Okay, let's say A is equal to X. All right, so again, we always start when we use the set builder notation. All elements X, such that X is an element of. That's where we're going to use this notation here. Element of the natural numbers, and that's where we're going to use that n again. So A is the set of all elements X, such that X is an element of the natural numbers, and that's indeed the natural numbers right there. So you can see then the whole numbers. All right, we'll call this set B. Is a set of all elements X, such that X is an element of those whole numbers. And then the integers, we'll call that set C. And it's the set of all elements X, such that X is an element of the integers. All right. So let's get away from these number systems, and what I'm going to do is I'm going to describe a set for you. Okay, I'm going to tell you basically, what the elements are, and then what I want to do is I want to write it in, set builder notation, and then I want to write it in roster method, so you can just see the difference here. All right, so let's do some inequalities here. So this is a strict inequality. So X is less than A. So if I say something like, write the set, okay, in set builder notation and then in roster notation, X is a natural number, so we're going to do all natural numbers. We're going to use this notation here. Natural number and then less than 4. Okay. So in set builder notation, it would be X such that X is an element of the natural numbers and X has to be less than 4. Okay. All right, so go back. What exactly are the natural numbers? So the natural numbers start at 1. So there's no 0, no negative. Okay. So what are the natural numbers then? Less than 4? So sometimes it's easier to see it in roster method. It's just 1, 2, 3. And I'll rewrite that just so you can see the natural numbers like that. All right, so this one here, x is less than or equal to a. So this is an inequality where you can include a. So x is a natural number less than or equal to 4. So in set builder notation, x such that the element x is an element of the natural numbers and x is less than or equal to 4. Well, what numbers would that be? Well, because it can be less than or equal to 4, it could be 1, 2, 3, or 4. So, I mean, obviously you can see here for these example, roster method is easier, but you know, set builder notation here also perfectly defines the set. So then you could have x is greater than a number. So let's write the set of x is a natural number greater than 4. So x such that x is a natural number, x is an element of the natural numbers, and x is greater than 4. Well, if it has to be greater than 4, that would be the numbers 5, 6, 7, and going on forever. It could be greater than or equal to. So x is a natural number greater than or equal to 4. X such that x is an element of the natural numbers, and x is greater than or equal to 4. Well, here that would be the numbers because it's greater than or equal to. It would be 4, 5, 6, 7, and so on. All right, let's look at compound inequalities here. Compound inequalities. All right, so here, this is x is greater than a, but then less than b. Okay, x is greater than a, but less than b. So it has to be between these two numbers. So x is a natural number greater than 4 and less than 8. So in set builder, it would be x, a element's x, such that x is an element of the natural numbers, and it's going to be greater than 4, but less than 8. So what that would be, that would just be the numbers 5, 6, or 7, because you have to be strictly less than. And strictly greater than. All right, so then you can have the equal sign under it, and then you can see that it has, you know, equal sign can be under both inequalities or under one here. So look, let's do this. X is a natural number greater than or equal to 4, or and less than or equal to 8. Okay, so this has the equal sign under both. So x, such that x is an element of the natural numbers, because we said it has to be a natural number, and it's got to be greater than or equal to 4, but less than or equal to 8. So that would be the numbers 4, 5, 6, 7, and 8. All right, let's try this one. X is a natural number. In this case, it's greater than or equal to 4, but then strictly less than 8. So x, such that x is an element of the natural numbers, and it's going to be greater than or equal to 4, but then strictly less than 8. Well, that, because the equal sign it could include 4, it would be 4, 5, 6, and 7. And then now here this is a greater than and then a less than or equal to. So x is a natural number greater than 4, but then less than or equal to 8. So x, such that x is an element of the natural numbers, and it's greater than 4, but less than or equal to 8. So it can't include 4, but it can include 8. So it would be the numbers 5, 6, 7, or 8. All right, let's end this lecture talking about something called the empty set. Okay, so the empty set. The empty set it's also referred to as the null set. Is a set that contains no elements. Okay, no elements here. So they can be represented by two things. It could be represented by a set of empty curly bracers, so it's blank, there's no elements in it. Or this symbol right here, it looks like a 0 with a line through it. It's just saying that the set has no elements. So if you look here, here's some examples of empty sets. If you say, the set of all numbers less than 4, but then greater than or equal to 10, you can't be less than 4 and then greater than 10. I said greater than or equal to, but you can't be less than 4 and then greater than 10. So this here is the empty set. It's, got no elements in it. Or the set of elements x such that x is a dog that speaks French. It's like the dogs don't speak French. There's no dogs that speak French. So that would be a set that has no elements. And either one of these notations is totally fine. You could do empty bracers, or you could do the 0 with the line through it. Okay, so which of the following, this is what we'll end on here. Okay, which of the following is the empty set? Okay, so look at this one here. This one here, it looks like the curly bracers with 0 in it. That's not the empty set. Remember, the empty set needs to have bracers with nothing in it. This right here is the set of a set with the element 0 in it. That's it. So it's a set, and it's a set with one element, just a set of 0. Here, this is not the empty set, right? This is just the number 0. Remember, it has to have this notation here. And then finally here, x such that x is greater than 5 and less than 3. Yeah, there's no number that satisfies that. So this is the empty set. Okay, we're going to follow this lecture up talking about subsets and then Venn diagrams coming up soon. So, we'll continue on this, and I hope this was a good introduction to just the basic terminology of sets for you.